Thank you for tuning in to Dyno Insights. In this episode, Mike and Chris will be discussing hydraulic dynamometers, also known as water brakes.
How you doing, Mike? Good to see you.
Doing well. How about you, Chris?
Oh, doing okay, thanks.
Good to hear.
It's good to get together today, talk a little bit about dynos.
And what'd you do over the weekend? Just tell me what you did over the weekend.
I was tuning up a dyno.
Really?
Yeah, I've got an old DPX3 in the garage I've been restoring.
Yeah, I remember we were talking about what you're doing with your garage and the floor lift, and I'm envious. Because I have none of the above.
No, it makes for a useful play area to try different things.
That's cool.
But if we're going to talk about dynos a little,
Sure.
you've been around the field for a while, so do you want to start off and talk about your background a little?
Just a little bit. I've been around the field for just a little bit, going over 30 years, and it's been interesting. I've been fortunate, actually, Chris, because I've been able to get involved with the design of engine test cells early in my career, and from there, the build, and then after that, the operation of test cells in a testing environment. So I've had the unique fortune of working with small engines, go-kart size engines, all the way up through ship engines and dynamometers related to testing those.
Oh, very good.
You've had some experience in the background in this as well.
Well, yeah, I started with small automotive engine testing back in the UK. Quite a bit of time in race engine testing, which was fun, using water brakes through that period, and it was really before the AC dynos came into that field. And then moving on to testing in the US, that's been more sort of large gasoline engines and light truck engines has been my area of experience. So not as broad as yours, so more specialized in some areas.
Well, I think the uniqueness about your experience has been the engineering side of it and the application from engine performance and understanding of the engine. So from an engine understanding, I think you have a pretty good understanding of the engine, how it relates to the dynamometer. So that's a pretty good package.
Well, I think that helps with some other questions that we'll be coming on to later in terms of how to size the dyno, how to specify what sort of testing we should be doing. But perhaps before we get into that, you could tell us a little bit about the different dynos we could be looking at in this field.
Yeah, so the three different types, the main types of dynamometers, and there's variations or variants of that, but there's three main types. So you've got your eddy current dynamometer, you've got your water brake, and you've got your AC dynamometers or AC motors. Now, those are all what we call rotational load devices. Two of them are absorbing only, which is the eddy current and the water brake, and then you've got your AC, which is basically related to doing transient test capability. Is having that full transient test capability would be through an AC motor, AC dynamometer.
Oh, that's great. Thanks for that explanation. If I look back at what I was doing, it was using water brakes on smaller engines, but perhaps you can tell us which other industries we might see a water brake.
So some of the other industries are going to be aviation, large engine, portable. It varies, but the larger business as far as dynos are concerned when a water brake, it's aviation. But I think before we spend too much time about talking about it, I think we should talk about the keys to the determining the right dynamometer, or the correct dynamometer to utilize. Because with that, there's a ton of questions that you would ask to really hone in on it. And everybody has their own constraints as far as whoever's purchasing it, but there are some basics that you need to go through. And it's a long list, but there are some basic, and understanding the requirements or the test specifications are crucial to making that investment. Wouldn't you think so?
Absolutely, and understanding, as I say, the specialized nature in some areas, going for a particular high-speed application or a high torque application, knowing what you're trying to test for becomes very significant in those early discussions as we go through the selection process.
Exactly. So continuing where you were starting to go down the path of the applications and the industries, if you look at, just take for example, the aircraft or the aerospace industry, and everybody uses different terminology. It's just what I'm used to is calling it the aerospace industry. But with that, you've got some very high-speed, high-power applications. And to give you an example, this may be a turboprop engine that's being tested that runs at extremely high speed. And the water brake is the perfect application for that because there's no other dynamometers that can really do that, have that control and have that ability to run at high speed and high torque. But with that, there's also the low speed, high torque, where the water brake also shines as well. And to give you an example, when I joined Froude, the first opportunity I had was in San Francisco, and it was a military installation, and that was involving a dynamometer that spins roughly 250 RPM, absorbs about 2 million newton meters of torque, and stands probably close to 18 feet, 16 feet tall. So pretty big application. Yeah.
So that's obviously one of the big extremes, but I've also seen water brakes operating on racing go-karts and some very small engines as well.
So have you had any experience working with the smaller engine side of things?
I haven't run a dyno with a go-kart. The smallest engines I've run have been around 1,000 cc's for small cars back in Europe.
And a lot of that had to do with racing, right? You're involved a lot with the racing industry.
That's correct, yeah. So we'll be looking at the higher speed and the higher power, not necessarily as much low-speed development as for a road car. Mm-hmm. And I guess for some of the go-karts, then you're looking at a broader range of how that engine operates.
Right. So with your business that you were in at that period of time in your career, I would assume some of that was transient. Some of that was with the race business. Was that transient capability?
That's right.
As well?
Yeah, it was important that the cars would accelerate as well as brake and everything. So the transients were very important. Yes.
Cool. Very neat.
Yeah. But as we talk about the different applications, the small dyno for the go-kart has typically been a portable dyno that can be adapted to an engine quite easily. Have you done some work on those machines?
Yeah. The smaller size ones, I mainly dealt with either replicating rotational loads from a front engine accessory dress, whether it be an alternator, power steering pump, or otherwise, to simulate those loads, or something that you need to bolt to the back of the engine. So at Froude/GoPower, we have applications where we have dynamometers that were built for portability. They were built to design to be put on the back of say for example, a diesel engine, like a Cummins product or a Caterpillar product. But it's able to bolt to the back of it and do your testing with minimal disruption, fairly efficient.
So you don't necessarily need a specialized engine stand. You can actually fit the dyno straight up
Correct.
to the engine.
Yeah, exactly,
Okay.
Exactly.
That's very must make it very flexible in testing.
Mm-hmm.
But as we look at that range of applications, I mean, obviously pretty extreme. What would you say is the water brake's biggest advantage, within this industry?
So what industry are you referring to? The overall or aerospace or?
Well, looking at engine testing, and we're talking about the water brakes covering quite a broad range. I just wonder where they stand the best. I understand the control can be very tight and very specific for water brakes.
Yeah, funny story on that one, Chris. That when I first looked at buying a water brake dynamometer, I was extremely concerned that it wouldn't have the controllability that I needed. Bear in mind, I had already been purchasing and utilizing eddy current dynamometers. So when I came across an application and an opportunity to purchase a water brake, I read up on it. And again, this was early in my career, and I talked to people in the industry. And people that weren't aware of their true capabilities and performance characteristics, there was some stigma going around as far as its controllability. What I found out, though, is its controllability is quite good in its accuracy to control. And to give you an example, recent opportunities that I've visited customer sites, I've seen the Froude product running and spinning at speeds of 6,000 RPM and controlling speed to plus or minus 3 RPM. So that's extremely tight control for any type of dynamometer that you're utilizing. And again, we're talking about a high power application on top of it. So it was eye-opening to actually see, when using the right product with the right control system, how well a water brake can perform.
Well, Mike, that's pretty amazing to hear about such specific control. Would you like to talk a little bit about what you see as the future for the water brake then, if we're following on from these advantages?
Yeah, the demands in the industry keep growing. When I say that, I mean things are spinning faster, power is not going down, it's going up, and it doesn't matter whether it's aerospace or NASCAR, for example. The demands they're getting greater and greater. And again, that's speaking to speed and power and the ratio between the two. Dynamic performance is also going to be part of the equation, but for the industries that the water brakes are in, That's the biggest demand in where we're building the future. And that includes, again, I digress a little bit, but we also make inertia flywheels, and those need to spin at the same RPM as the dyno spinning. So it's pushing the boundaries on speed. And by doing so, it's separating further the other types of dynamometers because of the direction it's going in. So the water brake's going to be around.
No, that's true, and it's good to hear about applications where we're spinning, up to and above 30,000 RPM and absorbing huge amounts of power. So it's an impressive machine.
Yeah, it is.
Would you like to wrap up a little bit with a few comments?
Yeah, I think the one thing I would want to get across is understanding the test parameters. So when you're selecting a dynamometer, water brake or otherwise, you really need to understand the parameters. And when I say parameters, it's not just speed and power. You really want to understand the application, the dynamic performance requirements. There's a list to go through. And at Froude, that's exactly what we do when we're speaking with customers, is we ask a lot of questions. It's not for being a pain in the butt. It's for getting them the product they need. And they may not know all the questions to ask. And that's why you want to come to industry leaders or experts in that field, so they know what questions to ask to determine the proper dyno to use. So when it comes to the water brake, we talked about its strengths and weaknesses, being the high power ratio, speed versus high power, also with the low power. But the stigma has always been, or seems to be, for people that don't have a lot of knowledge and background in water brakes, is that it's controllability, which is not true. So I think that kind of surmises the whole discussion that we had, and hopefully we were able to give enough information to keep that interest going and give us a shout.
Okay, Mike, well, thank you very much for that discussion. I look forward to getting together to have another chat in a couple of weeks on the eddy current dynos and AC dynos, and we'll see where those technologies are taking us.
Sounds good, Chris. Good speaking with you.
Good to talk with you.
Thank you for listening to Dyno Insights, presented by Froude. If there are any engine testing topics you'd like us to discuss, we'd love to hear from you. Please email us at podcast@froudedyno.com.